Yes, guys. Hello, guys. And operators, it means some symbol. It's nothing but is basic symbols that are used in Python. For example, let me put some symbols. Is equal to, or plus, minus, or multiplication, or divided by. I guess this is the divided by or floor division or remainder. These are all operators in Python. We have many other operators also. We will discuss everything in when we dive deeper. Now, yeah. Now in Python, we literally have seven types of operators, and every different operator has its own different function. Like we have seven here. Arithmetic operators, they are for doing some mathematical calculations and everything. Plus, minus, into, by, integer division and everything. Floor division and remainder, everything comes under arithmetic operators. Membership operators, they check whether something that is specified is does it belongs to the given data set, or it does not belong to the given data set. It just tells us whether it's present or not, whether it is a member of the given data or not. Relational data operators, they are nothing but just showing some relation. In general mathematics, we have greater than, less than, equal to, greater than or equal to, greater than, less than or equal to type of operators. The same thing applies here. In relational operators, we have greater than or equal to, less than or equal to, everything like that. And identity operators, they are nothing but checking the similarity of the variables that we provide. They just check similarity in the address. Just remember this point: is and is not check the memory allocation, or the memory that is allocated, or the ID of the or address of the memory that is allocated, are same or not. But in and not in, it's just similar to is and is not, but they check whether the member is present or not. If 3 in 1 2 3 4 we give, it will say true, but is and is not, they are little bit different. They just give us whether the memory or address stored is equal or not. Assignment operators, it's nothing but just assigning some value to the variable. Like if a equal to 3, here we assign by using is equal to, and a plus equal to 3 means a equal to a plus 3. We will get everything clear when we dive deeper. Assignment operators is for assigning the value to the variable. Main function of assignment operators is assigning value to the variable. Bitwise operators, they are nothing but our bitwise functions that we had covered in our previous graduations and everything. Bitwise or, bitwise and, bitwise XOR. Bitwise and, if both are true, it will return true. If bitwise OR, if both are false, it will return false. Bitwise XOR, if both are same, it will return true. If both are not different, it will return false. And logical operators, it just similar to the bitwise operators, but here in bitwise operators, it checks from bits. It checks from deeper inside bits. But here logical operators, here it just checks the condition. These can be called as conditional operators also. Logical operators can also be mentioned as conditional operators. They provide some condition, like if when we use and, the both statement should be correct. When we use or, the both statement should be false, if or false. And this is the main basics of Python operators. Let me dive into the code for everything. In operators, we have arithmetic operators, And next we have membership operators. The third one we have relational operators. Assignment, identity operators, assignment, identity operators, bitwise, assignment operators, bitwise operators, logical operators. Yeah, these are all the operators that are present inside Python. First, the use of arithmetic operators, I already mentioned, it's just only for mathematical calculation. Let me dive deeper into arithmetic operators. The first one in arithmetic operators is plus, addition. Generally, in mathematics, we have general operations like addition, subtraction, division, multiplication, and remainder. These are all the general operators in our numerical system. Same way here, we have 5 operators. Addition, it's plus. Minus, it's similar to hyphen. It's subtraction, it's similar to hyphen. And next one, star, it's multiplication. And we have 2 divisions here. One is floor division, when single slash. Double slash goes for integer division. And percentage symbol, it goes for remainder. Let me mention it. Addition, subtraction, multiplication. This is floor division. We get decimal value in the output. Floor division or floor division. This is called integer division. Int division. We can call it float division or float division. This is integer division or floor division. Int division. Now we have remainder operator here. Let me put something here like a. Let me take some basic data. A equal to let me take 34. B equal to 45. Now when I put A plus B, this is very easy operator. I mean addition operator. We get sum of it. This is addition plus symbol for addition operator. Now A minus B, it's for subtraction. A into B, it's for multiplication. But here you will get a small difference in division. A by B, and let me put print A double by B. Print A remainder of, percentage symbol indicates remainder. Now let me check the whole thing. Now A minus B, 34 minus 45, it's 11. And A into 34 into 45, it's 1530. But here you can see some small difference here. Like A by B. A by B here you can see 0.7555 something. Here the output is float. Here the output is in decimals, but in double, I mean when we use integer division, the output is only integer, is only integer. And you know what is remainder. Here in Python we apply percentage symbol for remainder. When 34 is divided by 45, we get 34 as a remainder. That means let me reminder. Here you can see a is equal to a by a mod a integer division of b plus a remainder of b. You can check this will work out true, because a by a integer division of b is 0, a remainder of b is 34. A equal to 0 plus 34, the value of a is 34. You can it's just like quotient, I mean it's just like the value is equal to quotient plus remainder, something like that, quotient into the original value or something like that. Are we clear with arithmetic operators so far, guys? Any doubts or anything you need further in these arithmetic operators?
No.
Fine with everyone?
Yeah.
Yeah. Now let's go for the next operator. It's membership operators. Membership operators. The main operators in membership are in and not in. These are only two operators. When we check, the word itself says membership, whether it checks he is a member or not. We'll be having some card, right? Membership card or something like that. When we have that card, they will give us like you have a member. Otherwise not in, whether he is not there or not, then you will get false. Let me show you by example data. A equal to 1, 2, 3, 4, 5, 6. Okay, 6, 7. Now b equal to 4. Let me now print b in a. It's true. Here you will get the output value as a boolean. I already mentioned boolean, it's very important in loops and everything. Here we get only boolean, but for arithmetic operators the output is integer or some numerical value. For arithmetic operators the output is numerical data type, because we are only applying on numeric, like we are only doing it on numerical data type. And here in membership operators we get boolean value as a output. Let me print 5 in a, it gives false. Print 10 not in a, it just checks whether it's present or not. There is no more work for membership operator, it just checks whether it's present or not. That's it. And here we get output for membership operators as bool value. The output is bool value, because it's just asking some condition. It's just making us we are just checking whether it's there or not, whether it's not there or not, like that. So based on our condition or data, we will be getting true or false only. And next operator, it's relational operator, one of the most important operators in Python. Relational operator. Here also we get only bool value. We get bool value only, bool value only, because here the main symbols are in general mathematics we have less than symbol is this one, greater than it's this one. and equal to equals to. In Python we don't use a single equal to here, we put double equal to for equals to. When we have to check whether both are equal or not, we have to put double equal to, like two equal to symbols should be used instead of using single equal to. Equal to is, I mean single equal to is an assignment operator where we use in our further class, like equal to. Next, less than or equal to. This is less than or equal to, and greater than or equal to. This is the symbol. Now let us try with some data, like a equal to 34, b equal to 56. Let's try all the operators here. A less than b, yeah, it's less than b. Print a greater than b. Print a equals to b. Print a less than or equal to b. Print a greater than or equal to b. Yeah, these are the five. I think all the operators are covered. Let me run it. Here you can see a less than b, 34 is less than 56, so true. A greater than b, 34 is not greater than 56, so false. A equal to b, 34 is not equal to b, so false. A less than or equal to b, yeah, a 34 is less than 56, so again true. A greater than or equal to b, so false. 34 is not greater than equal to. And this is all about relational operators we use for some conditions. You can see whenever we have for loop or while loop or if loop or everything, we will be mainly using like membership operators and relational operators. We'll be mainly using only these two operators in every loop. These are most important operators in Python. And because we get, wherever we get bool value, wherever we get boolean value as a output, we use that thing. We use the things in loops, while loop and for loop and if loop, wherever the boolean output is coming, and remaining things we use for assignment and something like that. Let me go deeper. And are you clear with membership operators and relational operators? Tejashwi?
Yes, I get.
Yeah, fine, right? I will be moving further. And the next operator, it's a relational operator, it's completed. And identity operator, we will check it at the last. Let me go for assignment operator at the start. Identity operators, we can cover it at the last of the class. Assignment operator, because it is bit confusing with membership operators, so I will take it at the last. Assignment operators, they are for assigning value to a variable. We need assignment operators, like yesterday I told, we use operators for assigning some value. These are the assignment operators which are used for assigning a value to the variable. And examples of that are is equal to, it's not equals to, it's equal to, or assign, and plus equal to. We have arithmetic operators covered here. Plus equal to, and minus equal to, and into equal to. I will tell you what is exactly this thing and everything, what exactly these states. And by equal to, like that, by equal to. and something like that. Let me go deeper. When I say a is equal to 3, then I will print it. Print a. Then it will print a value as 3. The first operator is equal to. We are just assigning the value. Assignment operators, they are for assigning value to the variable. They are just for filling the container, the memory container of variable. Now when we check for next, a plus equal to 4, let us do it. Now print a plus equal to 4 means this can be stated as a equal to a plus 4. This is short form of a plus equal to 4 is short form of a equal to a plus 4. Now you can see the value is 7 because a equal to a plus 4. This is the short form of it, plus equal to, and a minus equal to 4 minus equal to 5. This is short form of a equal to a minus b, like a minus 5, not b, 5 here. Print a. Let me print it. Now you get 7 minus 5 because a minus equal to 5. The short form of a equal to a minus 5 is a minus equal to 5. You can write every arithmetic operator using is equal to, which becomes as an assignment operator. And a into is equal to 2. Let me print a. Now we got 2 into 2. This is a equal to a into 2. 2 into 2, it's 4. Now a modulus of 2, a modulus by 2, a by 2, a by equal to 2. Now let me print a. Now you can see this is a equal to a by 2. We are just reassigning the value. These are all short forms of whatever I mentioned in the comments. Now we have 4 by 2, and this is floor division. Here we get decimal. That's why here it is mentioned 2 here. And when we take a by is equal to 2, a integer division is by 2 is. Now when we print it, now we get only 1. We don't get any thing after that decimal also. We get only 1 because it's integer division. And a by 2, a remainder is equal to 2. We can print a. Now we got 1 as, let me cancel it. Yeah, now you can see 0 as a output, because when we divide 2 divided by 2, we'll be getting only 0 as a remainder, and it is equal to a modulus of 2. I already told you percentage symbol, it's for remainder here. A equal to a by 2 by 1. Yeah. Now we have covered these assignment operators, where we assign some value for the variable. Here we at the start we used a plus equal to 4. It is short form of a equal to a plus 4. We are just assigning the value again, instead of doing instead of writing a equal to a plus 4, we are just writing a plus equal to 4. It's just a short form of assigning operators and everything. This is all about assignment operators, where we use every arithmetic operator. Every arithmetic operator combined with equals to becomes an assignment operator, and we have one extra thing, equal to operator, which is for assigning a value. This is all about assignment operators. The next operator that we are going to look into is bitwise operator. Yeah, the next one, bitwise operator. bitwise operators. I already mentioned it's nothing but uh, counting bitwise, and we have bitwise and bitwise or bitwise XOR, and we have right shift, we have left shift. Guys, you know binary system where we'll be putting some zeros, and wait, let me tell you one thing. uh, Print bin binary. Let me tell you one function for seeing a binary of a bin of 12. Yeah, for checking binary number, the thing used is bin. Bin is the function used for checking binary number. Yeah. Now we can see 0b means binary. Then we have one binary value of 12 is 1100. Now bitwise operators, they all deal with the binary thing, like binary value. Let me print binary of 12. It's 13. Let me. Here you can see the binary value of 13 is B1101. Now let me print bitwise, and just a second. Here the symbol for bitwise are print bit 12. Let me assign them to a variable a equal to 12, b equal to 13. Let me change it like here also, bitwise b. Now when I take the symbol for bitwise AND is just the AND symbol in your keyboard. Bitwise OR is just pipeline symbol that is given there. Now you can check bin of A and B. Bin is binary number. You can check here if both values are true, then only it's true. Here 0 1 is there in the last term. It's false because both are not true. This is the use of bitwise and let me print the value also. Let me print the value also, A and B. Yeah. Here you got 12 as answer. Now let me go for bin A and A or B, A bitwise or B. Here we get comma A or B. A or B comma A. It's a little bit confusing, so please just concentrate. I will again come back to the same concept. Here you can see if both just general way bitwise AND, if both are true it is true. Bitwise OR, if both are false then it is false. Here you can see if both are false in the third number, it's both are false, so it is false. 1 1 and the last number one thing is true, so it is true. 1101, the number is 13 we got. And the binary, you just check only the binary numbers. Bitwise operators deal with binary system. Bitwise operators deal with binary system. Yeah, binary. They just look into the inside binary numbers, like in the values inside the binary. Like now let me print a XOR symbol. It's like it is this one, arrow, above arrow. Print bin of a XOR b, comma a XOR b. Yeah. Now you can see, if both are true only, if both are, here what happened, like I couldn't see what is it actually. It's left shift maybe. Let just a second. For bitwise XOR, it prints 1 if only one of the things is 1, or if both are different, if both are different, then we get 1. Here you can see the first two things in the binary number 1 1 1 1, they are equal, so we didn't get anything there. But in the last value only we got something like 1 here. If both are let us get into the thing when deeper. And we have one more thing, we have not, bitwise not, which is in the form of this symbol equal to. Now let me print bin of, here we use only one variable, not a, comma bitwise bin of not b. Here you can see the thing is in negative number. Yeah, let it goes. And when you see here bitwise not, print not a, it would be -1 to the number, and you can and print not b. When you do this, you will get minus of -1, like 12 minus of 12 minus 1. And when we do it for 13, minus of 13 minus 1. It makes the number negative. Like yesterday we got to know, like there were something for 1 we have minus, for reverse index or negative index we have some minus. This is same thing like that. Like not a, it just gives minus sign for it and put some -1 beside it. For 12 we will get -13. For -14, for 13 we get -14. Yeah. And for, let me print for not -14. When I print not of -14, I will get 13. The same reverse. When we have negative number, it will do plus for it. Minus of minus, it gets plus, right? So here we complete bitwise operators. Here, yeah. Guys, any doubts regards these bitwise operators? Yeah, should I be continuing it? Okay. The next operator, it's logical operator. Logical operator. It checks for the logic. It checks for the logic. We have operators like and, or, and have only three here, like and, or, and not. We have three things here. And as usual, you know, print a grade, here we get, let me, a equal to 9, b equal to 10. Print a greater than b and b greater than a. When I do this, we get false. Here both, for AND operator, both should be false, both should be true, both should be true, so as to get true. A greater than b, 9 greater than 10, it's true, but b greater than a, 10 is not greater than, sorry, a greater than b, it's false, b greater than a, it's true, but both should be true for getting us true. When I put print a less than b and b greater than a, I get true. We have to get both should be true for getting true. When I try for OR operator, a greater than b or b greater than a, when I do it, I get true, because only single thing should be true. If both are false, then only if, we get false. Like, let me do something. B greater than a or a less than b greater than a. Yeah, b less than a or a greater than b. Let me do it. Now we get false because both are false. This is the main thing in logical operator. And print not of a greater than b. We get the opposite thing. A greater than b, it's false, but we used not operator, so we get true. Well, it just gives the opposite condition for the thing. This is also bool value. Here we get output only bool value. This is also called as conditional operators also. Bool value. Now we have covered logical operators, and let us come from start. What are the things that we covered? We covered arithmetic operators, where we used numerical operations like plus, minus, multiplication, float division, int division, remainder. And next we covered membership operators, in and not in, where we check whether the person is member of the given data or not. Then after relational operators, here we checked whether what is the relation between them, whether it's greater or not. Here also we got bool value as output. We are just checking some condition here. And assignment operators, here we are assigning variable value to the variable. Here we can use every arithmetic operator continued with is equal to, as a short form of a equal to a plus 4 is a plus equal to 4. And next, bitwise operators. Here we got bitwise and bitwise or and bitwise not. This bitwise or it's not required as of now. And we got bitwise, and if both the bits are true, then only it will return true. Like 1100 Here both are true yet 11. So 11, then 00 it's false, 01 it's false. So we got 1100. Bitwise operators, it's similar. It checks inside the bits. But logical operator, it checks whether the condition is not or wrong or not. It doesn't go inside the bitwise bits or something like that. We only see here condition or statement. Two statements are right or wrong, or if both are right or wrong, if anything is right or wrong while using or. And the final operator, it's identity operator. Identity operator. The main operator is and is not. It the main function, it checks whether address of the variable is same or not. Let us check listing. And we have one function named id for checking address of the variable. We have id. If I create a equal to 3, print id of a. Now we got some id. Now b equal to 3, print id of b. Here you can see we get both the values are similar, as whenever the value, this comes under garbage collection. Whenever we have similar value, we will get the same id. It will store in the same address. Same value is when I put like c equal to 4 minus 1, then print id of c. Even now we got the same thing. Wherever the value is similar, we get the same id. This is because garbage collection, because of garbage collection in Python. This is the most important interview question in every interview that is regards Python. How is memory managed in Python? How is memory managed in Python? It is done by using garbage collection. How is memory? I will tell you deeper when I go deeper, or when we have time I will just discuss this concept, garbage collection, memory and handle in Python, or memory management in Python. Yeah, that's fine. Here you can, but when we have some list 1 equal to 1, 2, 3, list 2 is equal to 2, 3, 1. When we check id for it, print id of a, list 1, print id of list 2. Here you can see there is some difference here. So when I take one more thing like set 1 is equal to 1, I should open with flower brackets 1, 2, 3. Yeah, flower brackets. Now I will have one more set 2 is equal to 2, 3, 1. When we check id of these both, set 1 comma id of set, id of set 2, when I check the id of it, here we can see both are not equal. Whenever I print 1, 2, like set 1, set 2, whenever I print it, we get the same output, but they are not similar. Here now we can use logical operators here. Print a is b. we use is b. Print list 1 is list 2. Print set 1 is set 2. Print set 1 is equal to here you can see is operator is similar to the thing but not exactly equals to, because here you can see the id, wherever the id changes it gives false. It only checks the id. A is b, the first the ids of a and b are same, so it gave true. List 1 is list 2, the ids of list 1 and list 2 are different, 496 and 736, so it gave us false. But set 1 is set 2, even though both are similar, both are same, the output is same but the address is different, so we got false. But when I put set 1 is equal to set 2, then we got, when I used relational operator here, I got true. So is not similar to is equal to. Now fine.